So, today is your reading break. Although meron tayong gagawin na konting activity. So, konting recall lang tayo into doing yung beam analysis natin. So, from your ES 102, ano ba natatandaan natin sa ES 102? Sa ES 102, tinuro sa atin yung Newton's second law and yung Newton's third law. So, kung ako yung prof nyo, ito palagi yung pinang-bring up ko when we discuss yung internal forces, yung beam analysis, and even yung frame analysis. So pag sinabi natin na Newton sa second law, so sum of all forces is equals to mass times acceleration. Pero since statics tayo, nauwi lang tayo into sum of all forces to be equal to zero. So therefore, dapat walang motion na nangyari. It has to be in static equilibrium. But if we mention Newton's third law, meron kang external forces is equals to internal forces. Paano ba natin madidistinguish ngayon yung external forces sa internal forces? Ito yung medyo tricky. We need to shift yung paradigm ng konti because when we, for example, deal with a simply supported beam, halimbawa ganito, so ang upbringing natin palagi is if meron kang distributed load, just like that, meron kang omega like this, if you sum all forces to be equal to zero, and even i-sum yung moments, may makukuha kang reaction forces. And yung reaction forces na to, ang pagkakaturo initially ay para siyang internal force. Parang yun yung external force mo yung distributed load, and yung support reactions mo are yung reaction. So reactions are not internal forces. Rather, they are external forces din. Ito yung kailangan natin na i-distinguish. So, external forces yung support reactions. Apart from that, yung supports mo would also act as your restraints, which later on i-discuss natin. Pero konting browse-browse lang muna. Scroll tayo pababa. So, paano ba mag-pan? So, tumatanda na tayo. So, teka lang. Okay. So, if we sum all forces, right here, syempre, makuha kang reaction forces. But what does Newton's third law pertain to? So, if, for example, i-analyze ko lang, pinutol ko halimbawa yung beam. Tapos, again, meron akong external forces na applied pa din dun sa section na yun. Then, meron ka pa ring reaction forces na applied dun sa part na yun. So, meron ka pa ring reaction forces right here. So, papangalanan lang natin na RA, tapos papangalanin din natin na omega ito para hindi rin tayo malito. These are your external forces. But by cutting yung plane, meron kang na-expose na internal forces. So, meron kang internal force dito. So, yung internal na lateral force na yon would be your shear. And yung normal force, again, normal force, which is yung along the axial ng member. Parang ito yung definition ng axial force mo. Pero dahil puro lateral forces lang, if nagsum ka ng forces along x, since tinreat natin yung horizontal to be along x, ma-determine natin na equal to zero as of the moment yung yung normal force mo. At the same time, meron ka ring na-expose na tinatawag na moment. Internal na bending moment. So itong tatlong forces na to, is what Newton's third law pertain to. And if we combine this with Newton's second law, sinasabi lang na this is in equilibrium still. So, kapag na-determine mo yung M, yung internal bending moment, kapag na-determine mo yung axial force, which is yung internal axial force, which is yung N, normal force, then if na-determine mo din yung shear, kapag ito lang yung ina-analyze mo, for example, yung left hand side, yung pagkakaputol ko dito, kapag pinutol ko yan, yun nga, na-expose ko siya, this is still in equilibrium. So, para ma-determine nga siya, so if, for example, pinutol ko siya over some distance x, yan, pinutol ko siya over some distance x, so alam ko na yung distansyang to ay x, we can then make our analysis. So pag kinuha natin yung analysis na yun, wait lang. Wait lang, wait lang, wait lang. Controls, nasa yung controls. Okay, so, and sorry sa konting patalastas. So, given that it's supposed to be in equilibrium, we can do again the analysis knowing that the section portion of the beam is at some distance, has some length x. So, if chinek natin yung equilibrium, so summing all forces along x to be equal to 0, since wala kang axial force na nag-act upon dun sa beam mo, what you'll determine is yung normal force mo, and ititreat natin to as a function of x is equal to 0. And if we're mentioning lateral forces, dun tayo mag-sum ng forces along the vertical. So, best na kapag nag-ano tayo ng summation na sign, maglagay tayo ng convention. So, nilalagay natin na upwards ay positive. So, summation of forces along y is equal to 0. So, if we were to do that, meron kang RA na upwards, tapos meron ka pang V, and again, iti-treat natin to as a function of x na upwards. So, hindi siya yung V times x, V as a function of x, shear as a function of x. Then, meron ka ring downward na distributed load. So, W times x. Yun yung length niya para makuha yung katumbas na na concentrated load. So, line load is omega. So, omega na yung gagawin nating call sign. So, yung length is x. So, to get yung concentrated load, multiply mo lang yung line load, yung uniformly distributed na line load, dun sa length niya. Kaya meron kang Wx. And this is supposed to be in equilibrium. Then, for moment, maganda na nagsasum ka ng forces at yung distance x from the length from the left-hand side para hindi nakasama si V, hindi nakasama si N. So, mangyari lang dito, equal to 0. So, meron kang R sub A na nagko-cause ng ng clockwise na rotation. Therefore, negative yung term niya. So, ito yung force upward. Then, yung moment arm niya is X. Length X. Then, meron kang uniformly distributed load. So, yung uniformly distributed load, if ito yung kanyang concentrated load, so definitely positive yung niya, yung rotation na kinukos niya. So, meron kang plus, ito yung concentrated load. Then, yung location ng centroid niya is x over 2. Yun lang ba? Siyempre, meron pa tayong since na-assume natin na counterclockwise is positive, so positive na m as a function of x is equal to 0. So, nire-recap lang natin lahat. And once na sinolve natin siya, makukuha natin dito is particularly sa makukuha natin dito is RA. Yung RA pala na solve na natin kanina. So itong RA na to, klikan natin to. RA, kapag dito ka naman sa buong system nag-solve, is equals to WL over 2. So RA is equals to WAL over 2. So sorry, may na-skip tayo na procedure. So ginawa mo yung analysis ng buo, then ito is already known. Dapat known na siya. So omega L over 2, that is positive. Therefore, kapag plug in natin siya sa second na equation, so if yung sa summation of y natin, f of y to be equal to 0, this will give you Vx to be equal to, so sinubstitute lang natin, nilipat sa kabila, meron kang Wx minus WL over 2. Yan lang naman siya so far. So negative yung shear. Then, pag nag-sum ka ng moment, be equal to 0, makukuha mo rito is yung m as a function of x, known na si RA. And this will give you WL over 2 times x minus WX squared over 2. So yung WL over 2 times x is this term right here. Yung WX squared over 2 is this term right here. So nire-arrange lang natin siya punta sa right hand side. So ito ang palagi nating magiging recurring theme not only in beam analysis but also in plane structural analysis. So, determine ko lang paano ko may usog siya pababa. So, dapat may usog siya pababa. Pababa. Paano ba ang pan? Tutubo tayo sa Zoom na whiteboard. So, bagong whiteboard tayo. Ayan, sige. Bagong whiteboard and therefore, pwede na nating ma-identify yung tinatawag na moment functions. So from your ES 102, pinagawa tayo ng shear and bending moment diagrams. Actually, yun din yung gagawin natin dito sa C18. May kasama nga lang na axial force diagrams din. So, moment functions would compel us to define what's called Macaulay function. So, pag sinabi Macaulay functions, typically makikita mo to. Meron kang m sub x is equals to WL over 3, for example. Tapos meron kang ganito na parenthesis minus WL L squared. Ano lang naman. Sige. Over 2. Tapos meron ka pang WL over 3 x minus 3 squared and so on. So pag meron kang gantong moment functions, what does the parenthesis, this type of parenthesis mean? So pag sinabi mo na Wx minus L, sinasabi lang niya is, sige, gawin na nating equal sign. This is a piecewise function on which if x is less than L, meaning this term right here becomes a negative value, this is equal to 0. But if x is greater than L, then the value exists. Siya kung positive na value siya. So kung negative na value, hindi siya kasama. Pag positive na value, hindi siya kasama. So ganito, sinimplify yung procedure na ginagawa natin all this time dun sa moment, shear, and bending moment. Ay, parang sa paggawa ng axial, shear, at saka bending moment diagrams natin. Yung mga functions na nakukuha natin from that. Mga graphs. So, paano ba siya na-derive? So, ano natin, atakin na natin yung bawat isa. So say you have a simply supported na beam and you have a force acting at the midpoint, and if you do yung equilibrium equations to get yung reaction forces, which again, iterate ko, are your external forces, meron kang P over 2 dito, meron kang P over 2 dito. So yung magiging moment function mo, pag nag-cut ka dito, is iba kumpara kung nag-cut ka dito. Kasi kung nag-cut ka dito, nag-cut ka on the left hand, yung before yung concentrated load P, ang matitira dun sa beam mo ay meron kang P over 2 right here. Then, say you have distance X and you have a shear and bending moment. Again, these are functions of X kung saan mo siya pinutol. So kung saan mo siya pinutol, may na-expose ka na internal shear at saka internal bending moment. So if we were to solve yung equilibrium equations, makukuha natin dito is V sub X. So summation of forces along Y will be equal to P over 2. Ibig sabihin, tama yung in-assume natin na direction, na downward siya. So, nagka-cancel out lang. So, kailangan in equilibrium nga. Dapat. And moment, again, itong P over 2 at saka yung V as a function of X is forming a couple, which is causing a clockwise na rotation. And to maintain na in equilibrium siya, dapat yung internal bending moment has to counteract that external na clockwise rotation by having an internal counterclockwise rotation. So if we were to solve this, halimbawa nag-sum ka ng moment doon sa point kung saan mo kinat, so yung P over 2 lang yung magiging concern natin na nagkakos ng clockwise rotation. And meron kang distance X, so meron kang P over 2 times X. So ito yung shear at saka bending moment functions before yung concentrated load. Pero after the concentrated load, so meron kang P over 2 dito, so meron ka ng P, tapos again, meron kang distance X right here, and dito mo siya pinutol. Ang question is that parang ano na magiging itsura ng shear at saka bending moment na functions mo. So, again, summing forces along Y will give you, so meron kang P, so meron kang P over 2. So, kailangan yung ano mo, shear mo is, so ano lang, let's talk, mag-segue muna tayo. Let's talk a bit about conventions. So if we're speaking about conventions, again, kapag nag-cut ka, so pag ang tinira mo ay yung left side mo, yung positive na shear is downwards. V sub x. Yung positive na moment is M sub x. Kapag nag-flip yung sign dyan, ibig sabihin, mayroon kang nakuhang negative na value. Ibig sabihin, negative yung shear mo, negative yung bending moment mo. And this rings true, again, nakalimutan ko palang i-mention, by invoking yung Newton's third law. So, kung, halimbawa, nag-cut ka nga dyan, so may natira ka on the other side na ganito, so pinutol mo, parang hinudini natin, and may expose tayo na shear and bending moment. So, yung bending moment mo dito, clockwise yung positive, then upwards na shear, yung positive na shear. Kung tinitignan mo from right to left. So, kung left to right, downwards ay positive na shear. So, downwards na dito. Then, counterclockwise is positive na moment. If you're going right to left, then mag-flip yung conventions natin. Yung shear, up, positive na shear ay yung upwards. Then, yung yung clockwise na moment ay yung positive na internal bending moment. And this actually, again, in equilibrium ito, in equilibrium din to. Then, kung ano man yung makuha mong magnitude ng V sub x dito, equal siya dun sa magnitude ng V sub x na makukuha mo dito sa right-hand side. So, these are equal, these are equal. So, this is in equilibrium, this is in equilibrium. So, kapag pinag-add up mo yung dalawa, magka-cancel out lang siya, babalik ka dito sa original na na system. So, balik tayo. Anong mangyayari dun sa shear and bending moment? So again, yung V sub x mo, so magsasum ka ng forces along Y, and that is to be equal to 0. So meron kang positive na P over 2, meron kang downwards na P, then meron ka ring downwards na V sub x is equals to 0. So yung V as a function of x will be equal to, magiging equal siya to, so lilipat lang siya sa kabila, so negative P over 2. So ibig sabihin, baliktad yung side. So in reality, upwards dapat yung shear if we're looking from the left. So if you're going from left to right. And kung nag-sum ka naman ng moment to be equal to 0, makukuha natin dito, pag nag-sum ka ng moment dito sa point na to, so meron kang P over 2, which is causing a clockwise rotation. And that, yung moment arm niya is x, yung distance x na yon. Then, yung P, ito pala, alam natin na, kalimutan ko na concentrated load at the midpoint yung case na natin. So, if concentrated load at the midpoint siya, meron kang, this is causing a counterclockwise rotation, therefore positive yung contribution niya, pero meron kang L over 2 dito, and meron kang X. So, therefore, etong length na to is X minus L over 2. x minus L over 2 plus m sub x to be equal to 0. So solving for m as a function of x will give us p x L over 2 minus plus p over 2 times x. Ngayon, we need to draw yung similarities ng equation dito sa left-hand side before yung concentrated load P and after yung concentrated load P. Compare ko to side by side, merong both na P over 2 and merong kang P over, naging negative P over 2 lang din siya. On the other hand, meron kang dito, meron kang P over 2x. Yan yung common term niya. Pero yung sa una, wala siya nito. So, paano natin gagamitin yung Macaulay na functions? So, if gagawin natin yung Macaulay na functions, sabihin natin, yung moment is P over 2x. Therefore, parang it exists talaga across its full length. Pero, meron kang negative P x minus L over 2. Sini-state lang niya na if negative, kung meron kang value ng x such that this gives this term right here gives a negative value that will be equal to 0. So, therefore, magiging mauwi siya sa ganito, magre-revert siya to this. But if x is greater than L over 2, this becomes a positive term. Therefore, this exists. This becomes this term right here. So, yun lang naman yung Macaulay na function. So, may mistake ko palagi yung from year CE 24, I believe. So, yung inyong Taylor series. So, yan. Magsasawa na kayo sa mga Taylor. Now, we move on dun sa pag-derive ng the rest. So, pasadahan lang natin siya. May bagong whiteboard na naman. So, na-solve na natin to. Isa-isay natin. So, meron ka isa, dalawa, puro simply supported beam. Gagawin natin mga simply supported beam. So, simply supported beams. Eventually, what you'll be able to solve for yourself is yung makikita nyo dun sa study guide natin. So, sorry, popost ko din yung study guide. Study guide on the superposition method on which you get to familiarize yourself with the basic beam loading. So, yung mga basic beam loadings natin ay hindi naman hinugot out of thin air. So, again, balikan natin. Meron kang P at the midpoint. So, meron kang L over 2. So, that's the first na case. Tapos, for example, meron kang P. Tapos, meron kang A. Tapos, L minus A. Or B. Minsan, tinaterm na lang as B. So, yung P as a function of A. Then, meron ka ding uniformly distributed loop. Then, meron ka din, for example, na triangular loop. So, ganitong triangular loop. Then, meron ka din ganitong triangular loop. So, ito yung mga basic beam loadings for simply supported beam. So, na-atake na natin to pa isa-isa. So, unahin lang muna natin yung moment function ito. Moment function niya is equal to, na-solve na natin kanina, P over 2 x minus P x minus L over 2. Ayan yung moment function natin. Ito magiging tricky lang. Pag sinolve natin to, Etong term na to will be P times L over A over L. Itong term na to is P A over L. So, hindi naman trust me ito. Parang this is also under the topic of influence lines, which I think hindi naman na-cover sa ES102. But you can solve this yourself. Pag nag-sum ka ng forces along Y and nag-sum ka ng moment, ito yung makukuha mong values for the reaction forces. And with the external forces being mapped already, meron ka ngayong M sub X is equals to, yung positive na term is P L minus A over L times X minus P X minus A. Ito yung Maclaurin function. Macaulay na function. So meron ka ng moment function for this uniformly distributed load. So length L. So this is WL over 2, WL over 2. And again, this is yung W mo, which is yung line load mo. So yung line load would have a moment function to be equal to WL over 2 times X. Tapos, recalling yung nangyari kanina. Ano ba nangyari kanina? Meron kang minus W X squared over 2. Ito yung moment function mo for that. So, totoo naman kasi isipin nyo, parabolic siya na function. Ito, pag minap mo to, itong second na equation, triangular siya na function. Ito, parabolic na function. Tsura ng moment diagram niya ay ganito. Yun lang naman siya. And yung maximum ay nangyayari sa mid-span. So, ayan, mamap na natin yung Macaulay na functions. And ito, medyo tricky lang yung triangular load natin. So, sa triangular load natin, kailangan nating i-distinguish muna, halimbawa, ano yung solely na effect ng triangular load. So, kung yung triangular load mo ay may omega na highest, pinakamataas na line load mo, so, halimbawa, nag-cut ka at distance x, ang concern mo for this is ano yung height nito. But alam mo na omega ito, and at distance L, so total length niya, alam mo na omega, and at distance x, hindi mo pa alam yung height ng triangle mo. So, lalagay lang muna natin, map muna natin to, then i-trace natin to. Etong part na to lang kasi yung kasama dun sa left hand side kapag kinat mo. So, anong nangyayari? Judy Ann Santos ba? No, parang walang nangyari. Hindi, may nangyayari yan. So, we use similar triangles para makuha yung W as a function of X. So, kung ano man yung highest na point. So, ano bang pwedeng magandang ipangalan dito? Sige, ano na lang. Talagang question mark na lang. Si question mark ay equal to, we use the concept of similar triangle. So, lalagay lang natin si question mark dito. Over X is equals to W over L. Therefore, si question mark ay equal to WX over L. So, yun lang naman siya. So, kung meron ka ng WX over L dito, then meron ka na ring WX dito. Then, gusto mong malaman ay yung ambag niya sa sa bending moment mo, so nasaan yung concentrated load nito? Nandito. Anong magnitude ng concentrated load? Again, yung area ito. So 1/2 times base times height. So yan yung concentrated load mo. Ito rin, coincidentally, yung contribution niya sa shear function mo. Pero, to complete this, ito ay may distance na, anong distansya niya? This is 2/3x. This is 1/3x. So, kino-consider lang natin is yung moment arm nitong distributed load. Ay, ng concentrated load. So, meron kang m sub x dito. M sub x will be positive. Then, positive din yung somehow based sa tsura. So, positive. Then, yung moment arm niya is x/3. Then, yung ano niya, yung kanyang magnitude ay equal to wx² / 2l equals to 0. And therefore, m sub x is equals to wx³ / 6l. This always rings true. Again, kung gagawin natin Macaulay function, gagawin lang natin siya na ganito. To tell na halimbawa, mayroon tayong case na nagsistart siya at some distance a. So, pwede natin gamitin. Ang magiging ano lang niya, ang magiging Maclaurin function niya is wx minus a cube over 6l. So, yun siya. So, yun yung i-invoke natin dito sa triangle na part. So, sa triangle na part, ano ang nangyayari? Ang nangyayari dito is paano natin atakihin tong triangle? Siguro, before that, discuss natin a little bit about isa pang special na beam loading. So, buburahin ko lang lahat ng nagawa natin dito. Naka-record naman to. Hopefully. Hopefully na-record nga. And meron kang m sub x, again, lalagay lang natin to. So, ito ay merong so, yung support reaction nito at the left-hand side will be equal to, sulat ko lang, ito yung magnitude niya, WL over 2. Then, yung magiging multiplier niya ay 1/3. Yun kasi, ganun kasi kalayo. 2/3, 1 minus 2/3, yun yung magiging value niya. So, ito yung magiging reaction force at the left-hand side. And this is to be multiplied by x. Then, gagamitin natin yung kanina. So, meron kang W. Since nagsistart naman siya sa pinakadulo, x cube over 6l. Hooray! So, yan yung Macaulay function sa itong triangle na to. And actually, kaya ako kinol yan, magagamit natin later on dito sa kapila. So, paano ba natin atakihin this time? So, sa pag-atake nito, ay meron kang we need to discuss. So, kailangan natin i-derail ng konting discussion. Discuss natin what if yung distributed load mo is at some distance A. So, or for example, ano lang, for the sake, para madali lang, sige, at some distance A. So, ito will become L minus K. So, solve natin yung, yung concentrated load niya. If meron akong omega rito, yung concentrated load niya will be equal to W for omega times L minus K. Ito yung concentrated load niya. And it's applied at, nalagay lang natin na A plus L minus A over 2 from the left-hand side. So, yung support reactions mo, ngayon, ito na yung papangalanan natin na R1 to, pangalanan natin na R2 ito. So, sa pagkuha ng support reactions, nagsum ka ng forces along Y, nagsum ka ng moments at one of the points, may dalawang systems of equations ka, meron kang dalawang unknowns, masasolve mo to. Pero malaking advantage talaga kung alam niya yung influence lines. So, ma-determine na natin agad kung ano yung value ng bawat isa. So, yung value ni R1 is equal to kung ano man yung concentrated load. So, yung concentrated load is W L over A multiplied by yung fraction na to. Yung fraction na tinutukoy ko is L minus A over 2. So, lalagay natin yung 0.5 dito divided by yung total length niya. R2 will be kung ano man yung 1 minus niya. So, W L over A, then meron kang 1 minus L minus A, 0.5 divided by N. So, yan yung R2 mo. So, parang napapansin yung parang, weighing functions ah. So, actually, yun lang yung magiging recurring theme niya. So, knowing this, may makukuha ka na moment na function. So, ano yung magiging Maclaurin function natin? Yung R1, R1x, then yung omega mo only starts at x minus a. Ba't ko binara? X minus a squared over 2. So, katulad lang nito. Pero meron lang x minus a kasi it started at a. So, ito yung moment function. And syempre, expand pa natin. Substitute natin yung R1. Haba nito. W L minus a squared over 2L times x minus W x minus a squared over 2. Yan lang naman siya. Ito yung moment function mo. So, dito na tayo papasok sa principle of superposition. So, hindi natin ataklihin ng diretso ito. We treat this as if, so ito yung tinutukoy ko, ito, we treat it as if meron kang mga sub-cases na pwede mong superimpose upon one another. So ano ba tinutukoy ko? So itong triangular load na to can be treated as if meron ako nito. Isang malaking dire-diretso lang. And again, kung papangalanan ko ng omega to, so kung omega dito sa midpoint, so L over 2 ito. So therefore, dito is 2W. So W pala, W, omega. So ito yung unang case. Yung second na case is that kailangan mo siyang bawasan. So minus na babawasan natin siya ng upward. Ay, ibabawas natin to. Sige, solve na. Babawas natin to. Itong case na to. So similar siya dun sa nagawa natin kanina. So kung binawas natin yan, then idadagdag natin si to. So kapag ito binawas ko dito, mangyayari ay so check muna natin. So ano lang, rationalizing muna. So ang kalalabasan niya ay meron kang hanggang sa midpoint. Tapos biglang didip. Pag ganito, tapos ganyan. Actually, yun nga. So, ah okay. Sorry. Ito, mali yung second case. Actually, yung ibabawas mo ay yung pasinolve yung una. Ang ibabawas mo ay mini triangle right here. So from the midpoint, so L over 2, then this is W. Yan yung ibabawas mo to reach this. Nga lang, kailangan natin makuha yung reaction forces. So yung reaction forces ay equal to, again, ang unang step is kunin yung yung distributed load ay yung katumbas na concentrated load. Yung katumbas na concentrated load niya is WL over 4. And it's located at a distance of L over 6 from the left end. So L over 6. So this will become 1 over 6. Kasi if dinivide mo by L, maka-cancel out yung L, magiging 1 over 6. So yung masasolve mo, R1 is equals to 1 over 6 times WL over 4. And actually, yun na yung information na pwede natin kunin. So Nx mo is equals to WL over 24 times X. Tapos, yung formula nung sa triangle natin. Minus W X cubed over 6. Tapos yung L mo is L over 2. So this will further reduce to, oops, ito ay magiging 3L na lang instead na 6L. 3L. Dahil nangalahati yung length niya. Okay? So ito yung equation for this one right here. Ibahin ko lang yung font. Ngayon, yung equation naman yung sa una, ay yung font color, alos kokopyahin lang natin, ang mangyayari lang is magiging 2 omega L over 9. Ba't 2? 1 omega L over 9 lang. Omega L over 9 times x minus, may 2 pa pala. May 2 nga. Twice pala. Twice. Tapos meron kang 2 omega x cube over 6L. And syempre, pwede pa natin ma-simplify ito. Magiging ano lang siya, omega plus 3L na lang din siya. Now, to get this, kukunin mo lang yung difference nito saka nito. Magpa-minusin mo lang yung dalawa. So, makukuha mo dito, minus ko yung sa first term. So, meron akong 2 omega L over 9 minus omega L over 24, or rather, sige, para lang ma-appreciate lang. Ito, si-shortcutin ko sana. X minus meron akong okay. Okay. Sorry, may nakalimutan akong idagdag dito. So, correction lang, minor correction. So, apologies. So, this is x and this is x minus n over 2q. So, pag nangyari yun, meron kang ano ka ngayon for the second term na so, gawin ko lang to. So, meron kang mafa-factor out na. So, yung common term nila is omega over 3L. Tapos, multiplied by x cube minus x minus L over 2q. So, ito yung moment function. So, basically, what I did is I invoke yung superposition method. So, sinuperimpose ko lang yung basic beam loading from this para makuha ko ito. So that actually applies if chine-check natin yung displacements. Okay. Yung consistency ng displacements and even solving for displacements and for the redundant forces. So sa pagkuha nun, we need to familiarize yourself with the basic beam loadings, and I've already given you a problem set to solve. So it's a form of quiz on which you are to derive itong mga basic beam loadings and even yung deflections niya, you solve either dun sa mga trip nyong gamitin. So either kung double integration method or area moment method. Pero what I'll discuss here is yung paggamit din ng conjugate beam method. So yung makikita nyong mga reference tables dun sa study guide nyo will be your references for your application of the superposition method. So ito, basically yung superposition method in a nutshell. Rather than kung nakokomplikahan kayo sa isang basic beam loading, all you need to do is to decompose that into the basic beam loadings that you are familiar with. Then saka mo superimpose or either i-add or i-subtract yung mga basic beam loadings na familiar tayo. So it's all about pattern recognition. So that is the first method. So yun din yung magiging problem set. Hopefully, mapag-practicean nyo rin in your problem set how to do conjugate beam method. Sa conjugate beam method, as the study guide suggests, it is as if we are rationalizing how we come up with the moment function. And we do that, we try to make a parallel on how to convert yung moment function mo into your displacement function. So what do I mean by that? So meron kang basic beam loading. So loading. Anong kinalalabasan nito? Meron kang shear diagram. Diba? Then knowing yung shear diagram natin, or knowing din yung loadings na yon, makukuha din natin yung moment diagram. But knowing yung double integration method, basically, sinasabi lang, kapag in-integrate mo, so in-integrate mo to, pangit na differentiate. So, ano bang magandang ilagay? Ilagay natin yung paborito yung worm na figure. So, ayan. Pag in-integrate mo, mapupunta ka sa shear diagram. Pag in-integrate mo yung shear diagram, mapupunta ka sa moment diagram. And recall na kapag dinivide mo by EI, so meron kang EI dito, M over EI. Kapag in-integrate mo siya, meron akong slope. Kapag in-integrate ko siya, in-integrate ko pa ulit, meron akong deflection. Which is yung Y na value natin. So, rationalizing this compels us to draw a similarity on the approach. So, yung loadings mo is just the same as your M over EI diagram. Your shear diagram is basically the same as with your slope na function. So, moment diagram mo is the same as with your reflection. So, conjugate beam method stipulates that rather than doing yung mathematical na solution, we treat yung M over EI function mo as your loading for what's called the conjugate beam. So, sa conjugate beam, meron kang dalawang kailangang i-satisfy muna. How do you identify yung conjugate beam loadings? And how are you identifying yung conjugate beam supports? Sige. Mention muna natin si conjugate beam loadings. In doing conjugate beam loadings, what we will, instead of solve lang natin, for example, yung moment na diagram, gagawin pa natin yun, then mahihirapan pa tayo ng konti. Meron din tayong tinatawag na moment diagram by parts. So, paano ba natin i-approach to? So, kung meron kang, for example, halimbawa, sige, para lang ma-appreciate, distributed load. So, meron akong distributed load na W ulit. So, when we do moment diagram by parts, kailangan lang nating i-determine anong degree. So, una, ang unang requirement when we do moment diagram by parts, ito ang kailangan yung hindi makalimutan. Makuha nyo rin yung reaction forces. Kasama siya sa moment diagram by parts. So, kapag nakuha mo yung reaction forces, gagawa mo yung bawat isa ng moment diagrams. So, paano ba ginagawa yung moment diagram? We set a reference point. So, pwede kong sabihin na midpoint. Reference point ko is midpoint. Medyo mahirap yung midpoint. Pero sige. So, kung reference point ko ay midpoint, anong nangyayari dun sa una? Anong nangyayari sa loadings ko? So, yung concentrated load is considered to be 0 degree. So, when we do yung sorry, hindi siya 0 degree. Pag 0 degree ay hindi siya 0 degree. Ma-mention ko muna yung uniformly distributed load. If uniformly distributed load, yung degree ng function na to is 0 degree because constant siya. This concentrated load is negative 1 degree. So, parang, ano siya, ano lang, for reference lang. So, negative 1 degree. So, when we're dealing with this, ano yung kalalabasan niya ng moment function? Yung kalalabasan niya ng moment function ay madedetermine mo if you add 2 degrees. So, ito, negative 1 degree. Nag-add ako ng 2 degrees. Ang contribution niya is parang yung magiging function niya is first degree. First degree right here. And yung ano lang niya, yung magiging value nito, nung WL over 2 is base, kung ano yung magiging moment. Yung magiging, okay, yung moment arm niya is L over 2 kasi midpoint, yung tinutukoy, times WL over 2. So, meron kang W L squared over 4. Ayan. Yung, pero iusog ko siya dito. WL squared over 4. Yan yung height ng iyong triangle. So, it's causing a clockwise na rotation. Kaya ganyan siya. Sorry. Okay. So, ganyan yung itsura niya. And yung bending moment, since 0 degree siya, so meron kang 1 and 2 dahil 2 degrees yung tinaas mo. So, 2 degrees. Pero ano yung highest point? Yung highest point niya will be, again, meron akong W L over 2. Ito yung katumbas na concentrated load and it's located at L over 4. So, meron akong WL squared over 8 na maximum value. Meron akong WL squared over 8 right here. Then, yung magiging degree nito is 2 degrees. right there. And syempre, on the other side, meron kang, so this, yung distributed load mo ay baliktad na. It is causing already a clockwise na moment, kaya downwards. So meron akong, oops, kaya challenging yung midpoint. Hindi magandang pang demo. Pero sige, pwede naman natin ulit. So meron akong WL squared over 8 dito. Then meron akong WL squared over 4. Pero ito ay 2 degrees. Ito ay magiging 1 degree. So yan yung moment diagram by parts. Kung ang reference point mo ay midpoint. Kung ang reference point mo naman ay yung right hand side na support, yung right support, yung roller support, so kung ginawa mo yun, moment diagram by parts, yung WL over 2 would have, so kung ito yung reference mo, tignan mo siya, from that is causing a, kanya. And yung magiging maximum na height niya, and again, this is 1 degree, WL squared over 2. On the other hand, yung bending moment, ay yung distributed load is meron kang maximum height na WL. Ito yung concentrated load. Then yung location ng moment niya is L over 2. So WL squared over 2 din. So actually magka-cancel out in reality yan. So tapos yung magiging degree ng function mo is second degree. So ayan, yung moment diagram by parts mo if we were to do this. Ang kaibahan lang, at this point, after mag-moment diagram by parts, oops, yan, moment diagram by parts, if given na yung elastic na properties, pati yung iyong moment of inertia, divide lang natin by EI, ito na actually yung loading mo. Downwards to. Then upwards ito. So ito yung magiging conjugate beam loading spot. Okay, nasatisfy na yung una. Next, how do we define yung conjugate beam supports? Sa conjugate beam supports, we need to check yung correspondence ng deflections, both ng slope at saka ng deflection mo. So what do I mean by that? So pag tinanong sa'yo, tatanungin mo, wait lang, kailangan mo i-check yung restraints. Restraints. So yung restraints sa right end mo is equals to 0. Then, yung slope mo is not equal to 0. Same goes with the left hand side mo. Yung deflection is equal to 0 but the slope is not equal to 0 because walang restraint sa hindi naman fixed na support siya. This is not equal to 0. So left mo, hindi equal to 0. So lista lang natin. So VL is equals to 0. VR is equals to 0. Theta L is not equal to 0. Theta R is not equal to 0. How do we convert that? So, isipin mo na ang katumbas nito ng deflection is yung internal bending moment ng conjugate beam mo. So, ay dapat equal to 0 din. Internal bending moment ng conjugate beam mo ay equal to 0 din. Pero ito, yung slope ay katumbas niya yung shear ng conjugate beam mo. Katumbas ng shear ng conjugate beam mo, yung slope ng elastic function. So, not equal to 0. So, what type of support satisfies na equal to 0 dapat kapag end, tapos not equal to 0 yung shear? You have 5 seconds. 5, 4, 3, 2, 1. Ako, wala. So, simply supported pa din. Parang kahit pin na support siya, wala pa ring internal bending moment. 0 yung internal bending moment mo sa dulo, di ba? Kahit dito, 0 din yung internal bending moment mo. Same goes here. Check natin sa conjugate beam loading mo. Ay yung M over EI na loads mo. 0 yung bending moment mo dito. Tapos, meron kang WL squared over 2EI. Tapos, meron kang WL squared over 2EI. 0 din dapat dito. So, 0 yung bending moment mo rin sa simply support beam. So, therefore, yung conjugate beam na supports mo, tatapatan mo lang siya. This is also a simply supported beam. Kaibahan lang is kailangan nating makuha yung conjugate beam support reactions. Ito yung namimiss ng karamihan. So, meron akong RL. So, yung R dun sa left-hand side, lalagyan natin ng asterisk to denote na ito ay conjugate beam loading mo ay equal to. So, again, I only think of the concentrated na load. So, yung concentrated na load, katumbas sa concentrated load, nitong sa taas is WL squared over 2EI. So, ito yung height. Yung base is L. Tapos, syempre, ang ating paboritong value is 1 over N plus 1. So, second degree siya. So, 2 plus 1 is 3. Kaya 1/3 siya. Ito yung ito yung distributed na ito yung katumbas na concentrated load. Ito yung unang value na yun. And that is at a distance of N plus 1 over N plus 2. So 3/4. So 3/4, ito 3/4 L. Tapos meron akong 1/4 L dito. So knowing yung influence influence line ko and influence functions, alam ko na kailangan ko lang i-multiply ng 1/4 ito. Then finally, dun sa baba naman, base. So plus yung base nito times height. Ay base yung L, yung height ito. Tapos times 1/2. Tapos yung location nito is 2/3 L. So 2/3 L siya dito. Ito yung 2/3 L. And 1/3 L naman to. So meron akong 1/3 dito. RL ko will be equal to So, pa-factor out ko lang, WL squared over 2EI. Actually, gagawin ko ng WL cube para meron akong 1 over 6 minus 1 over 12. So, RL ko is WL L cube over, this is equal to 1 over 12. So, 24 EI. Ayan, yung left-hand side na support reaction ko. Then, all I need to do now, ito na. Gusto kong malaman, halimbawa, yung at distance x, ano yung internal bending moment ko sa conjugate beam loading. Ito ay actually equal sa elastic curve. Saya. Medyo happy tayo. Pero syempre, huwag natin kalimutan yung ating friend na si RL. So, meron tayong WL cube over 24 EI times X. Then, upwards yung yung sa triangular load. So, yung height is WL squared over 2EI. Tapos, meron ka pang 6L dito. Tapos, positive na pala to. X cube. Nga pala, wala pala tayo na-define na Maclaurin function sa sa parabolic na So sa parabolic na functions, we simply use yung bubura lang tayo. So konting segue na naman. So, pag nag-segue, maraming patalastas. Opo, patalastas. So sa patalastas na yun, meron tayong parabolic. So sa parabola, to medyo konting segue ulit. So if we're mentioning yung parabola alone, so second degree. So halimbawa, alam ko yung maximum na height. Gusto kong makuha yung H prime. Tapos meron akong L prime dito. Tapos meron akong L. Hindi actually mag-hold, hindi gagana yung similar triangles dito. Take note. Hindi gagana. Ang gagana dito is H prime over L prime squared is equals to, so kung ano man yung degree niya, yun yung naka-raise to power siya. H over L squared. So yung H prime equal to H times L prime squared over L squared. So, ayan, makukuha na natin yung at any distance x. So, for example, yung nga yung x. Alam ko ngayon na meron akong WL squared over 2EI times X squared over L squared. Then, knowing yung moment function ko, so ito na yung height. Mag-ano lang tayo ng ibang color. So yung base, so ito na yon, yung term na yon. Yung base is x. And to get yung yung so yung area under curve, so 1/3. So ito ngayon yung concentrated load. Bibigay sa akin ng concentrated load. Concentrated load na yon ay nandito. And it's situated at a distance of 1/4 x. So therefore, yung idadagdag ko ngayon dito is meron akong WL squared over 2EI times x raised to 4 over 1/4 x. So, over 12L squared. Ito yung elastic curve ko. So, 4th degree kung kalalabasan. Which is true kasi nag-integrate ka from this, yung distributed load, naging first degree, naging second degree, naging third degree, naging fourth degree. So 4 degrees. Amen. So more examples will be posted. So kita-kits sa Thursday. So post ulit ako ng extended topic on this. But as of now, pahinga muna. Enjoy nyo muna yung reading break.